Okay, so in this video, we're going to go ahead and approximate the area underneath this curve here, f of x equals x squared from 0 to 1. So I'm talking about this region right here, but we're going to do so using the midpoint rule with four equally spaced subintervals. So again, if we're using four equally spaced subintervals and we're going from 0 to 1, we need to first figure out what our delta x is going to be. So again, delta x, so delta x is going to equal, delta x will equal 1 minus 0 divided by the number of rectangles we will be using, in this case 4. So it'll be 1 over 4. So that means that if I space these out equally, I will have, let's say about there, I will have this as 1/4. So again, the distance here is 1/4, and if I add another 1/4, I get 1/2, and then if I add another 1/4, I get 3/4. If I add another 1/4, I get back to 1. Now the thing with this is that we know what delta x is. We need to now start constructing our rectangles. Well, we won't be using the left and the right anymore. We will now be using the midpoint of each subinterval. So I'll start by looking at this first one. I'm not going to do a left and I'm not going to do a right hand sum. I'm going to look right here and kind of make my dot in the middle, or my point I should say, in between 0 and 1/4, and create my rectangle that way. So there's my first rectangle. And then if I keep doing this, I'm going to look in between 1/4 and I will look in between 1/2, so about right here, and I will have my point to be about right there, and from there I'll sketch my rectangle. And let me just make this little line just to show that I'm going straight up. And then finally, or not finally, but we're almost there. We have this point right here in between 1/2 and 3/4 that if I go up, I will hit the curve about right there. So my rectangle will look something like that. There you go. It looks, well, that doesn't really look like a pretty rectangle, but it is what it is. And then finally, if we construct the last one in between 3/4 and 1, my rectangle will look something like this. Now, if I want to calculate, or if I want to start to calculate the area of each rectangle, well, I'm going to need to know a few things. For example, I already know what the width is of each rectangle. The width of each rectangle, for example, the width here is just delta x, and we already figured out what delta x is equal to. What I would like to figure out, is the height of each rectangle. Now that we don't have. We need to figure that out. So if I look at this first one and I think about, well, what is this guy right here? Well, what is in between 0 and 1/4? Now you can calculate this the same way we calculated delta x if you wanted to. You could do 1/4, or you could actually take the average. I think that would be better to do. You would do 1/4 plus 0 divided by 2, and that would give you 1/8. And let me actually just go ahead and erase this here to create some room. So if I erase that there, this point right here would just be this point right here. Let me see, where's my pen? Let me see. So this point right here would be, let's see, 1/8. And then if I continue doing this and I find the midpoint here, so 1/4 plus a half divided by 2, I would get, let's see, I would get 3/8. So this would be 3/8. And you can kind of think about it as 1/8, 2/8, 3/8, 4/8. So this one here in green would be, definitely it'd be 5/8. And then this one would be 6/8, and then 7/8. So we would have here 7/8. And these are all the x values that correspond to these points on the curve. So then their heights, so this height would be f of 1/8. And then we would have, in orange, we would have f of 3/8. And then we would have in green here, the height would be f of 5/8. And then finally in blue up here, we would have f of, let me do this in a brighter, color. We would have, let's say, f of 7/8. Not that that is much brighter, sorry about that. So to calculate the area, we have everything we need. We have the width and we have the height of each of these rectangles. So to calculate this first area here, it would be delta x times the height. So I'll have the height f of 1/8 times delta x, and then it's going to be plus the area of the orange rectangle here. So that'll be, let's say, f of 3/8 times delta x, and then finally plus the green rectangle. So that'll be plus, let's see, we said 5/8 times delta x, and then finishing this off, we have this area right here, which is going to be plus f of 7/8 times delta x. And again, they all have a delta x in common, so we can definitely factor that out as before. So again, I should label this here that this is M4. We're using the midpoint with 4 subintervals. So this is going to equal delta x, and if I factor everything that I can out, I will end up with f of 1/8 plus f of 3/8 plus, let's see, f of 5/8, and then finally plus f of 7/8. There we go. And let me just close off this with a bracket there. And I'm not going to go through the hassle of computing all of this and writing it out. I will leave that for you to do. But I just want to get to the total here. So I've calculated this separately. And what I got was 21/64, which is equal to 0.328125. So again, I encourage you to go ahead and calculate this, go through the process and calculate this and see if you get what I get here. But here's what the interesting thing is. It's kind of difficult to tell through my sketch whether this is an over or an under approximation. I will tell you that this is an under approximation, and in future videos to come I'll explain how you can tell when the midpoint rule will give you an over or an under approximation. It all just depends on your curve. But let's look at this number here, and let's look at it very, very carefully. If I In the previous video, we had the left hand sum, and we had calculated the right hand sum, and we found the average. And the assumption that we made was that, look, the average looks like the average of the left and the right. It would make sense to say that the average would be the midpoint. However, the area that we got for the midpoint was 0.328125, and if we go to what we had in the prior video, we calculated up here in the prior video, this is what we had on the screen. We calculated the average to be 0.34375. So again, the average of the left and the average of the right is not, we can say now that it is not equal to the midpoint rule. So if somebody asked you to do the midpoint and you didn't feel like doing the midpoint and you went ahead and calculated the left and the right and then took the average and gave that as your answer, you'd be totally incorrect, because again, we've just shown that the average, and this is very, very important, that the average of the left and the right left-hand sums do not equal the midpoint sum. So what does the average equal? Well, stay tuned, and in the next video we're going to do the trapezoid rule, and we're going to see what answer we get and compare that to the previous answers that we've gotten by applying the left hand and right hand sum.